Gravitational lensing. Sounds kind of complicated, right? But it's really not that bad. In order to understand gravitational lensing, we first must understand how the mass of a huge object has the ability to curve space. To demonstrate this, I'm going to use a soccer ball to represent an object with a huge mass, such as a planet or a galaxy. I'm going to use this bedsheet to represent space. Notice what happens when I place a soccer ball representing an object with a huge mass on the bedsheet. The bedsheet starts to curve inwards towards the soccer ball. This is similar to what would happen in space. The mass of a large object has the ability to curve space towards that object. Now that we understand how an object with a huge mass has the ability to bend the space around it, we can move on to understanding gravitational lensing. In order for gravitational lensing to occur, you need a light source, an object with a really large mass, and an observer. When gravitational lensing happens, an object with a very large mass is positioned between a light source and an observer on Earth so that the light source is directly blocked from the view of the observer. As previously explained, an object with a really large mass has the ability to curve space to create a kind of lens that light from the light source can be deflected off of, thus creating one or more new images of the light source in space that are visible to the observer. One of the specific types of gravitational lensing is called strong lensing. Strong lensing occurs when the mass of the object that creates the lens in space is extremely large. Therefore, it creates a bend or lens in space so intense that the light from the light source can be deflected off that lens at many different angles so that multiple images of the light source appear and are seen by the observer, sometimes even in a ring formation as shown in this diagram. Another type of gravitational lensing is called weak lensing. Weak lensing is very similar to strong lensing. However, the mass of the object creating the gravitational lens when weak lensing occurs is much smaller than it would be in order for strong lensing to occur. Because of this, the gravitational lens created by weak lensing is not curved enough or intense enough to create as many images of the light source as a strong gravitational lens would. Also, the images created by weak lensing are often distorted, blurry, or inaccurate depictions of the light source. However, if the size, shape, and appearance of the light source is known to science, scientists can use the level of distortion of the images created by weak lensing to determine the mass of the object that is creating the gravitational lens. The more distorted the image, the smaller the mass of the object. The less distorted the image, the greater the mass of the object. The third type of gravitational lensing is called microlensing. Microlensing occurs when the mass of the object creating the gravitational lens, and therefore the curve in space created by that object, are small enough so that the different light rays from the light source are not deflected off the microlens at different enough angles to create multiple images of the light source. Instead, all of the deflected light meets at one point, thus creating an image of the light source that is visible to the observer and brighter than normal.